Hi, this is Hugo Martinez doing a demo of Group J's ELEC0138 coursework. Our security system features a web app interface called Smart Home Securities for what would be a fully set up IoT home security system featuring a series of cameras primarily. The main goal of this particular web app is to allow the user to access the security film and ensure that they are able to access this whenever necessary. In order to facilitate the project, we did make some simplifications. Primarily, instead of featuring a real hardware implementation of cameras, we instead have the user upload the videos directly, as we felt this still allowed us to implement our security measures and thoroughly address the two primary threats that we noted in our threat model. The first being unauthorized access, which we are preventing via rate limiting on the login to prevent brute force attacks, as well as two-factor authentication, which sends a one-time password to the user in order to log in. The second threat was the possibility of data breaches or packet sniffing, exposing private information of the user. And in order to handle this, we're using many levels of encryption that I will discuss as we get to them. So here we'll go into the sign up and we will do a fake sign up. We'll do user3, last name tester, test address, test@gmail.com. Username can just be username1 and password. So again, hopefully the real thing is a lot safer than that. But as you can see, the sign up has been a success and that data has been sent to our MongoDB database. So not only does MongoDB's API already have encryption and security protocols enabled, we've gone a step further and built in a method of password hashing, which uses a blowfish cipher, which is a form of block cipher, to hash the password using a randomly generated salt that is unique for each user. So because this password is hashed, we do not need to store the user's plain text password, and without the plain text password, it is impossible to get that plain text back from the hash, even if you have both the hashed password and the salt. So we can see now we're here on the database and we'll be able to see the new user popped up. Here it is. Here's the hash password. Again, has nothing to do with the plain text. And here's the unique salt. As you can see, it's different from the salt of my profile. But yeah, so that is how we are protecting the user's password. But as I mentioned, we have also designed some ways to prevent brute force, and one of them is rate limiting. So the backend that we are using, Flask, has a built-in rate limiting method, and so we have incorporated that in order to limit the amount of attempts that you have to log in at once. So as we see here, too many requests, 5 per 1 minute is the maximum that we have. And so because of that, we're no longer able to log in. And this prevents brute force attacks for the most part, as it makes it pretty ineffective to go through an infinite amount of usernames and passwords and try and break in by force. But it doesn't prevent social engineering. And so we wanted to come up with a way to prevent that. Also, in order to reset, I just restarted the application, so we can now try again. But in order to prevent social engineering from being effective here, we've also implemented two-factor authentication. So using the information that the user provided, we now get a 6-digit code, which is 457775. So the user provides an email address and we use that to get this code. So we have, there we go. So we've passed in the two-factor authentication and the code has now led us into the profile page. So on the profile page, we see here that there's an upload and the downloadable files available to the user. So here we can quickly upload a demonstration MP4 file, which represents the security film that we'd have and show the encryption methods on the database end. So let's go ahead and get the MP4 file out. So I just have a sample. It's a video of the world spinning. But there's our example MP4, and we'll just call it test demo .mp4, and we'll upload that. So as we see, this is using Amazon Web Services S3 cloud storage. So similar to MongoDB, they have their own encryption methods and transfer protocols. So everything is pretty secure, communicating between the server and the cloud storage. But on top of that, we wanted to make sure that we did encrypt everything. So as we can see, if we refresh, there it is, testdemo2.mp4. And also, we must make note here that there is other content in the cloud storage that is not accessible to the user right now because all of this content has metadata that prevents other users from accessing them. But if we were to download testdemo2.mp4, we would see that we cannot view this video. We can open it in media player, but it says we cannot open testdemo2.mp4, save you the file, it's not supported, blah, blah. So it's encrypted on the database side and it's impossible to get in through there. So sorry, let me pull up the screen again. So yeah, so if we go back to the original page, we just up and refresh, we will see now that testdemo2.mp4 has popped up and we can download that with this link. And if we try to open testdemo2.1, we'll see that our beautiful picture of the globe is here. So as we watch the globe spin, I can discuss a little bit of the encryption that we chose. So for the encryption on this side, we are using the user's plaintext password and the previously generated salt in order to make a new custom encryption key. So this encryption key will be constant for the user every single time, which means that all of their files will be encrypted with the same encryption key. But that encryption key nor the plaintext password is stored anywhere on our servers or any time past the session, which means that nobody except the user can access, encrypt, decrypt any of this information, which makes it pretty secure. And yeah, so that concludes the demo, and thank you for watching.